Share my screen.
Recording is happening, so feel free to start whenever.
I'll give another 1 minute. Is everybody here, or maybe I should wait another minute or two? Oh yeah, let me my camera here. All right, I'll start in like 20 seconds. Okay. So everyone can see the screen, right? I can hear me. Okay.
Yep.
Loud and clear.
Yep.
All right, nice. Okay, so let's get started. Okay, so hello everybody. Yeah, today's lesson, today's talk is going to be on JavaScript call stack, and let's see. Oh, okay. So yep, these are our mission. I'm just gonna. Everybody knows this, right? So let's go to the agenda, the main thing. So today we're going to be talking about the call stack, and just going to be, oh yeah, so I got these pancakes from last year's slides. I thought this was pretty good. So yeah, I just used whatever last year had. So yeah, we're gonna talk about the stack data structure. I don't know why I wrote the call stack data structure, but the stack data structure. And then we're going to talk a little bit about, not too deep, but more a little bit about like JavaScript's memory model and how the stack actually fits in. And then we're going to go through some examples of tracing through the stack, and then which will basically a systematic way of tracing through things, because that's always something that always confused me. And yeah, so we're gonna talk a little bit about recursion, not too much, but I feel like after we go through some examples, when we get to the actual recursion part, we're not going to be like, most of you guys will have a very good understanding of how the call stack works and how functions work and all that. And then we'll finish up with some questions. So as always, I'm Yi-Chen, I'm developer at Kudo, and then my instructor, Michelle, I'm pretty sure everyone knows. Michelle?
Hello, hello.
Oh, yeah, you were already in the last session, right? You didn't leave. Okay. Cool. So first, what is the stack data structure? So for those of you who don't know what a stack is, it's actually an abstract data type. So it is a fundamental data structure that most people actually know or should know. And even if you don't know the official terms, it's used everywhere, in pretty much everywhere, and even in JavaScript, there's already built in. So in the array functionality, the prototype chain, you'll see that two of the methods are push and pop, and I'm sure all of you guys have used push and pop before, right? And so this data structure, which is called stack, is also known as last in first out. So it's essentially, you can imagine you have something going on top of each other. You can only take something on the very top, right? So here in the picture, you can sort of see you put something on top of it, you keep stacking, and then the last one that comes in, which is at the top, can be popped off or taken off. So that's the stack data structure. And so there's only really two options, right? I mean, there could be more options, but there's really only two options. And real life examples I can think of, I think Git, so the Git stash, we use a stack, right? And then, I don't know, I can think of, somebody said Magic the Gathering. Like, I know that when you, I don't know, play like a game or something, when you play Magic or something. I'm pretty sure whatever program is programmed in, somebody in there uses a stack, right? Whatever. So yeah, so that's what a stack is. And instead of me telling you what it is, I like to kind of build a little implementation of, well, we'll go through like a little implementation that I built. I just kind of came up with on the spot. And yeah, and so we'll first go, okay, so I already wrote this. I was going to do it live, but then I just, I'm probably going to make a lot of mistakes. So Carmen, you raise your hand. Do you have a question?
Yeah. What's more so, would you mind just zooming in a tiny bit?
Oh, yeah, right. Yeah, I forgot about that.
Thank you.
Is this good?
That's good for me, yeah.
Okay, yeah. Okay, cool. So what I did was, so I created a stack data structure. So I didn't use a class here. I just used a function, right? I called, what do you call it? I named this stack, and then we had two functionalities, right? Push and pop. And so pushing is just pushing on top of the stack, right? And then popping is just taking off the very top and then taking it off of the stack. And that's essentially it. So what I did here was I just, I made it so that when you create a new stack, you can already, it's kind of like this goes in first, this is 1, this is 2, this is 3. So this is kind of like what I'm looking for, right? So what I did was I just took dynamic arguments. I put in this array, right, as the main as the placeholder, and then here I put a little push and pop right here. This just adds it to the end of the array or the top of the top of the stack. And then here the pop, this just there's a splice on the array, so it just takes the last item from the array and then it just takes it out, right? So here, this print method that I wrote, it just prints out things where it'll just print it out in order. So let's go through. So I have a little example here. I put a stack right here, okay? So I initialize the stack right here. So this should be 1, 2, 3, or sorry, 3, 3, 2, 1. So when I print it, it should be something like this, right? 3, 2, 1 from top to bottom. Okay, so when I do this, click run, I should see. Let me do this here. Right. So you see the stack right here, right? Yeah, the stack right here. The 1 goes in first, and then the 2, and then the 3, right? And what I did for the print was I just printed from. So it goes from. So I just printed it like backwards, right? So that's how I'm able to print the. So because the first one that goes in was 1 and 2 and then 3, I printed 3, 2, 1, right? So that's why you see it like this. So what happens if I push 10, right? It will be, hopefully it will push the 10 to the very top. So we'll see 10, 3, 2, 1, right? So let's see if this works. So here I just print it out. I print 3, 2, 1, and then I push it to 10, and then I'm going to put a little divider here, the 3 dividers here, to make it easier. So if I do this, as you can see, the top is 10, right, on the very top. And then, of course, I can also pop it, right? So I'll pop off, let's just pop off 2 items from the stack. So the 2 items are 10 and 3, right? So hopefully this will give me 2 and 1, right? So if I do this, right? So this was before, right? Before okay, and then after, so 2 and 1, right? So pretty simple. I think most people would find this to be simple and easy to understand. So yeah, so now we know what a stack is, and we have our own little implementation of the stack. How does this, relate? Or as a JavaScript developer, we don't really think too much about uh, like what a C or a lower level developer thinks about. So this is a picture of kind of the memory model in C, or in general, how lower level languages would look at how the computer kind of, when it's running the program, this is what's going on. There's a little bit, there's a, this whole stack, not stack, but this whole picture here shows that this program is in memory, and it has a adjustable amount of space, right? So the height of it is the adjustable space. Uh, so there's actually a couple regions in this image. So the first one is the text. So that's our code, and then there's initialized data, uninitialized data. This is just basically variables and constants, and so usually they're all static, right? They're all kind of put into memory. And then there's the heap, which you guys probably heard of. It's the dynamic memory part, the part where if you're a C programmer, you would allocate X bytes into like an area of your code, so that you can put things into it. Like, so if you have a linked list, you need not linked list, you have an array in C, you would need to do an allocate on the amount of memory, right? And so JavaScript does all that stuff for you because it's a pretty high level language, and we don't really need to worry about it. We don't need to worry about freeing memory. We don't need to worry about, most of the time, we don't need to worry about this type of stuff. Like 99% of the time, work good, because the JavaScript garbage collector would dynamically be able to free memory and or allocate certain memory or bytes depending on how big a certain data structure is. Usually it's like a string or an array. So the stack is basically what comes after the heap. So the stack is the part of the program that is dynamic, and it's execute. So it's called it's called a stack because there are multiple stack frames, and every time a function is executed, okay, the stack becomes bigger. So when you have a function that calls another function, that calls another function, that calls another function, the part of the actual program that's running, okay, is actually the stack. And so the stack is getting pushed and pushed and pushed and popped off and pushed and popped off. And that's essentially how the program works in the background, the code. And so I don't know who is teaching the JavaScript event loop or event queue. So in JavaScript, there's, as you know, there's the event loop. There's basically another micro queue, or micro queue that actually lets you put things in the background. So what happens? So I'm not going to go into specific details. There's a lot of you can probably learn more for whoever is teaching that concept, after. But the idea here is the stack is whatever it is being executed at the moment. Okay, whatever the synchronous things, they're essentially executing from top to bottom. And so when you have like a big while loop, that's basically being executed on the stack, right? So that's why the stack is basically the blocking part of the application. And as when you get to the event queue, you know that when you do like a set timeout, the process actually gets, not the process, but the code or program or whatever it is, the function in the set timeout will get queued into another queue, and then it will be executed after everything in the stack has been executed, right? So that's why it is non-blocking. So so this probably summarizes most of what a stack is. Basically, a place to keep track of where we are in the code, so we can run the code in order. Essentially, the order of execution of your program, right? that's basically what the stack is here for, and it goes up and down, right? And so something that for me, I struggle a lot with, I think, probably in the beginning, or not necessarily beginning, but through most of my career, I think I knew about the call stack, but I didn't really know in detail. I didn't really kind of know, like I would know the theory, but then I wouldn't know how it kind of helps me to apply this kind of concept to my real life. And I'm sure most of you do this already, but when you are running functions and then those functions call other functions, right? You're essentially using the call stack. And when you're debugging it, you're essentially, in many ways, I guess, informally using the call stack, right? And so we're kind of going to go through like a lower level and actually see step by step how when functions are being called, how the whole stack works, and how the thing goes up and down, right? Like you push a bunch of stuff and it gets popped off, and then the order in which it happens, right? Which is the kind of the confusing part that that always got me, because that's why I struggle like many people. I don't know about you guys, but when I was like learning things like recursion and that stuff, a lot of people don't understand recursion, not because they don't understand recursion, but because they're unable to debug and trace through formally in detail with a diagram on whether things are happening, how things are happening in which order. And so we're gonna right now I'm just gonna go over some examples, right? And we're gonna learn. We're gonna do that together. So here I am going to, I'm going to bring up my code editor. Okay. So here's essentially the two rules that we'll get back to this if you forget. But there's two rules when it comes to tracing the stack and understanding exactly what is going on the stack when your program is running. So, and I basically just made these up actually like 2 hours ago. It's just basically, I didn't Google it or anything. I just thought this is from my experience, and this is pretty much how it works. Basically, anytime a function is called, you put that function, you push that onto the top of the stack. Okay, so you got an imaginary stack, right? Imagine you got a function, you just put it on, right? And then anytime that function terminates, so that function is running, you got 100 lines of code in there, and let's say there's a return, maybe there's no return statement, but at the very end, once it terminates, we'll pop it off the stack. So those are mainly the two general rules, and we're gonna go through an example right now and apply basically these two rules right now in a diagram. So here we have 3 functions, and what I'm doing is I'm calling 1, okay, and then I'm doing 2, and then I'm doing 3, okay. So I will comment this part out. So who can tell me what the output is? It's pretty simple. And you want to tell me the output? It's not a trick question. Anybody? Yeah, exactly. So Ryan, yes, you're right. I am 1, I'm 2, I'm 3, right? And you don't even need to really think too much about it. It's just, you just trace through the code, right? You just go, this is the order in which it happens. So we're gonna go through how the actual stack, how to apply knowing the concept of a stack, like pushing and popping, these functions, and how each step actually works in the background. So I'm gonna bring up, and we're gonna follow the code. So I'm gonna bring this up, and we're gonna see how this works. Okay. So I'm using Figma right here. So what's going on is we're gonna trace through the code, okay, line by line, right? And we're gonna see why it's IM1, IM2, start, and then IM3. And you know what? I think I'll put this right here to I'll put this right here so we can have a reference. So here, what happens is your main program, okay? So, okay. So you got your main program, okay? So this is the first part of the stack, okay? We're stacking one frame here, okay? This is the main program. So the main program has, well, we can see there seems to be one function that's being called, and the function that's invoked is one. Okay, so what happens is the computer goes, okay, all right, the JavaScript engine goes, okay, all right, there's a function that's being invoked that's called one. Let's invoke it, all right? And we go into the function and we see, okay, there's a console log, I am one, right? So now we gotta do this. So we continue what we're doing, right? So I'm just gonna write log, right? We write log, okay, right? So remember the two rules that I just stated on the top. Anytime a function call, put that function on top of the stack, okay? That's we're applying that right now. Okay, anytime, so rule number 2, anytime a function is terminated or it reaches the end, pop it off the stack, okay? So log is actually a function, right? So console.log is a function, right, of console. So in this case, we're going through this function, right? We're going in there and it's giving us, something to the standard out, right? I am one, right? So the I am one gets printed, right, to the screen, and then this thing gets popped off. Okay, so there's no more. So this thing, it's gone. It's popped off, right? Because we're at the end of console.log, right? Remember, rule number 2, very important. So now we continue. Okay, so we're continuing with the function, right? We're still at 1. We didn't pop off 1 off the stack, right? So we're gonna go here and we're gonna see, oh, 2 is being invoked. Oh, okay, I see. 2 is being invoked. Okay, what's inside 2? Oh, I see. So there's console log onto dash start. So again, same thing, right? Same thing. We got the log. We got the log, right? We're stacking it on top of our stack frames, and we get to the end. Log finishes. Like log doesn't call any other function, right? So we don't stack more frames to the top, right? We don't stack more frames to the top, and it prints this thing to the standard out, right, which is IM2 dash start. And so this terminates, and we pop this off the stack, right? We pop this off the stack. So now log 2 is going to be gone. Okay, so now we continue, right? So we're in 2, right? And we're continuing. We have 3, right? So with 3, we're doing the same thing, right? Same exact thing. We say, okay, there's 3, right? There's 3, okay, and it's another. We're gonna push this into the stack frame, okay, and then we see, oh, we have another function called log or console log, right? So again, same exact thing, right? And then again, we go into the console log. It terminates, and then it prints into the standard out, and then we get 3, okay? And so this ends, we pop it off, right? We pop it off, there's no more. So now we need to see, does 3 terminate? Okay, so 3 looks like it has terminated, right? Because there's nothing here anymore, right? So there's nothing here anymore. So 3, you're popped off the stack, all right? So now we go back to the previous stack frame, right? Where we go, okay, this is done executing, right? Let's go down. Okay, there's nothing here, right? So now, remember rule number 2, anytime a function is terminated, reaches the end, we pop it off the stack. So right here, pop off 2, right? We terminate. So we terminated 2. Well, 2 was called here, and same thing. There is nothing here, right? So 1 is terminated as well, right? So 1 gets popped off the call stack, right? And of course, our main program, right, are what we call, I think the term is like entryway or gateway, right, in JavaScript. or in other languages like C#, Java, it's called the main method, right? This that's running our program, it gets popped off the stack. All right. So now we terminate our program and we're done, and hence we have this, right? Is what we should be getting, right? So if I run this and I do this, right? We should be expecting this, right? And this is you know, the detailed way of tracing it through, and hopefully we are correct. Yes, we're correct, right? So now I think I accidentally scrolled down for a couple seconds there, but I want everybody to take a guess, or if somebody could take a guess. So I purposely commented this out. How would something like this show up? Like where would this be at? Where would this log out as? So right now we have this, right? Like would this be logged out here? You know, or anyone got any ideas? Like would this be logged out here? Right? Would this be logged out here? The IM2 end. Any ideas, anyone? Anyone? You just right. Okay. So whoever, Natasha, right? So you said it's gonna be here, right? Yeah. So that's true. Now, how did we get that, right? So we'll go through it again, and then we'll see why it's like that, right? So what happens is, okay. So let's can I? Oh wow. Okay. So you know what? Let's just do this. Let's just do this again. So here, if we start again, all right. So this is kind of the confusing part because you know this isn't I would say too complicated, but it becomes very complicated when you have like when you have multiple functions, and then those multiple functions have multiple console logs, or like or even if you have a for loop and it calls multiple functions dynamically versus me just having a fixed function, and those functions go in depth into more functions. That's where the tracing part becomes very important, right? So if we were to do this again, right? So let's go down. Let's go down and look at this again properly. So we have one, right? So main, okay, so main, we call one, right? And then we have one, which will console log IM1, and then we call, yeah. So I'm just gonna do this real quick. Yeah, we call one, right? And then console log comes out, and then we do yeah. So let me just do this real quick, right? So there's the yeah. So right, so we go here, right? We log it out, IM1, right? And then we pop it off the call stack, right? And then we do 2, right? So we'll do this very quickly this time. We do 2, right? And then we go, log out the second phrase, which is IM2 start, right? Which is right here. And then we'll pop it off the call stack. We'll pop it off the call stack, right? And then here, this is where it gets a little tricky, and this is where you're able to debug no matter what situation you are. If you know truly how it works in the stack, you would know which order it goes. So you would call 3, right? You would call 3. Oh man, not writing very well. So you call 3, okay? The 3 would go to the log, right, on line 22, right? And then you would get IM3, right? So this will be popped off the call stack, right? We go all the way back to 3. So, sorry, the 3 ends, right? So, sorry, the log ends, so we pop it off, and then the 3 ends, right? So 3 is no more, we pop it off the call stack, right? And then And then there's, now we see there's a log, right? So now we see there's a log on IM2, right? So when you do log, now we know that this order is correct and it comes after IM3, right? So of course, we can finish, let's just finish the rest of the program. So this gets popped off, right, on the stack. We end, the 2 gets popped off as well, right? And then the 1, right, we're here, the 1 gets popped off. Whoops, the 1 gets popped off, right? And then eventually we jump out to the 1 ends, and then the main will get popped off as well on the call stack, right? So that's how we arrive at this, at this output, right? So now we're gonna go and do something potentially a little bit more complicated, okay? And this is, I think, good practice for anyone, really. So now we're gonna do some more kind of multiple functions, okay? So we're gonna have like a more breadth and more depth, okay? So we're gonna have a one that calls 2A, okay? That does a console log in the middle, and then it does it calls a 2B, right? And then that 2A, right, calls 3A, 3B, and then the 2B, right, which is this one, okay? This one will call 3C, right? And then the 3 ABC, they're just gonna console out whatever it is they're gonna console out. So so if anybody wants to guess what the order is, well, you guys don't have to guess. I'm just gonna trace it through, and we'll see. Well, yeah, we'll see how having multiple functions, how knowing the call stack, it pretty much will guarantee exactly the order in which things are being executed, right? So let's do this. I'm gonna do it a little bit quicker. So here we have, of course, main, right? So this is our main program. We call 1, okay? So 1, we go into the function and we say, okay, we're gonna call 1 right here. All right, cool. This is our stack. And so for people that it depends on who you are, but for people that maybe never programmed before, maybe like you're very new to programming, and if I just didn't tell you about the call stack and you were not, and I said just use your intuition, most people would look at this and be like, I'm confused. Like, does this execute first, and then this execute? Because the one thing that people get confused sometimes is that they don't know that the call stack itself, it's essentially depth first search, right? So you're looking into the most, you're going to call a function, and then you're going to dig deep into that function. You're going to dig deep into that function until there's nothing left, right? And hence rule 2, which is when a function reaches then we pop it off the call stack, right? So for those of you who don't know depth first search, it's essentially what I just said. Imagine you're kind of going in a maze, and you're basically trying to go through whichever way it is. You're trying to go through to a dead end. Okay, you're trying to go all the way to a dead end, and then you're like, I'm going to come back, right? And then you're going to come back to an intersection, and then you're going to keep going in that route until you reach a dead end. And so that's essentially depth first search, and that's essentially what this whole exercise and this of functions calling functions on the call stack is essentially all about. So I see Dan has an output now, and yeah, we'll compare that to what we're going to do while we're debugging right now. Okay, so here we have 1, right, which is the function that's being called, and then we have 2. Okay, so 2A is being called. 2A, right? So 2A is being called, and don't forget that we're not at the console log yet. So IM1, it's not IM1, right? We got to go to function 2a, okay? Because it's depth first search, right? We're going to keep going until we hit a dead end, okay? So where's 2a? Right here. Oh, 2a. Oh, okay. Cool. So we got log. We got console log, right? And it seems like it's 2a, okay? 2a. So here in our output, we're gonna remember that, okay? And then this terminates, right? This thing terminates, pop it off the call stack, all right? So we're still in 2a, right? But looks like we go more into the program. We'll see there is a function called 3a. So we'll add that to the top of the stack. Then we're going deeper. So this is pretty deep, right? So now we got another log. So this is pretty simple. We know what the log is doing, right? It's logging 3a, right? It's logging 3a. Ooh, looks like I have the answer there. I'm just gonna delete this real quick. Okay, so we got 3a. All right. So again, we will the log will terminate, right? And then we'll pop it off the stack. So here, log terminates, right? Function 3a will terminate as well, and we'll pop it off the stack. Okay, pop it off. Nice. Okay, so so now we're gonna go back to. I'm actually getting confused here. 2a. Let's see, 2a, 3a. Right. So now we're at 2a again, right? And then we got to continue. Okay, now we got to go to 3b, right? So 3b, because we went to 3a first. So 3b, we're going to call it, and we're going to see what happens here. 3b, oh, another console log, right? So it seems like this whole stack is just is pretty big. So we're going to see IM3b, right? IM3b, right? And then same thing, the console log gets popped off the stack, right? And then the 3b terminates, right? There's no more code here, right? And then here, 3b gets popped off the stack. All right, so 2a, we're at 2a now. There's nothing left here, okay? So 2a gets popped off the stack. Cool, right? So now we go back to to 1, right? So it's the stack is helping us keep track. So 1, and oh, so we just finished executing 2a. So IM1 is going to be the next one, right? So again, I know I'm writing this like 1,000 times today, but to illustrate how computers is working, how a JavaScript engine is working under the hood, this is what's going on. So log IM1, right? And then right here, okay? So again, pop off the stack, right? So now we're still in 1, and then we go and we find ourselves now in 2b. Okay, so this is, again, just going through this example methodically, right? 2b, right? Oh, going here, there's 3c, right? There's 3c, so we'll push this to the top of the stack. Push this to the top of the stack, and then 3c comes in here. There's a console log right here. So again, log out, right? Okay, so again, this gets popped off, the log gets popped off, the 3c gets popped off, right? And then we're at 2b. Where's 2b? Where's 2b? There we go. 2b. So now again, there's another log, right? There's another log, right? I am 2b, right? Cool. So this gets popped off, right? 2b terminates, gets popped off, Great. And then we're back at 1, right? Now this finishes. There's nothing left to run in 1. 1 gets popped off, right? We go back here. There's nothing left in the program, right? Our main function or a gateway gets popped off as well. And so this is our output. And so let's see what Dan has. Okay, let's see what he has here. So you have, if you got it right, so 2A, 3A, 3B, 1, 3C, and 2. So good job, Dan. I'm sure, I don't know if you just wrote the code and then you ran it or something, but yeah, so yeah, you were saying?
It's all those, it's the years of playing card games, Chen, you know, you get used to deciphering stacks.
Yeah. So yeah, that was, I hope for those of you who are just watching kind of the 2 examples that I did, this is essentially what happens, not depending on who you are, but I don't like to just kind of go in and wing it and just not question how things work. I really like this kind of systematic way of doing things, because if you get into a large code base, maybe you can pull out this technique, right? And then you can start, actually debugging. It's like, okay, why is this thing happening first versus that thing's happening last, right? Because I don't know about you, but I can't just look at something like this, right, and just immediately, know exactly what it is. I have to trace through it, and if I trace through it incorrectly, I would go and do this manually, like how a computer will actually do through its actual stack frames. So let's see, Audrey asked what's going on with the call stack when you have a set timeout. Yeah, so that's more for the event loop or the event queue class lesson, whenever that's coming up. I don't know who's teaching it. I probably should have signed up for that and maybe combined this with that other class. I probably should have done that because they're very, very connected, right? So hopefully whoever's teaching that will teach you the event loop and how the microtask queue and how it works with JavaScript with the set timeout and the promises and all that stuff properly. So anyway, back to this. So this is pretty fundamental, and I'm not gonna go through. Hang on, I'm not gonna go through. So we just did this. I'm not gonna go through tracing something like this. So now that that you know how exactly it works. Okay, now that you know how to systematically debug and to figure out how things go in order, and that things aren't just random, right? You can dig into recursion and you can actually trace out things yourself. So here's a very common example, which is the Fibonacci sequence. This one, this really got me before because so I'm gonna show you guys a little piece of code here. So the thing that I think for me and when I talk to other people, when they see something like this the first time, they usually kind of look at this part and go, whoa, what's happening here? Like, what is actually happening in this part? And this is the part where if you understood call stacks and you understand how it is like a DFS, it's a depth first search, and the way to trace it and debug complex recursion problems, it's actually know the call stack very well. And so if you ever like done any binary tree questions or tree questions in general, or graph questions or any of those things where you would use recursion, essentially knowing the call stack is basically being able to debug and know the underlying details of how these recursive calls work properly, right? So like I said, when I first saw something like this, I would just be like, I don't know what's going on here. But as you can see, this I've kind of written in a way where it looks pretty manageable, because this looks very similar to this and this, right? It looks very, very similar. So if you can trace this, okay, if you can trace this, then you can trace something like this, right? And you can trace any problem that has like, for example, if you want to write a recursive function that traverses through, a directory all the way to the very end, right? You would it would be kind of confusing at first, but then when you start thinking about it, essentially it's just, it's just recursion, right? Like you just need to look at the base case first, and then you think about the recursive case, and if you're having a lot of trouble, you can debug it with what I just showed you, right? With the actual stack frames visually. Okay, so obviously I'm not gonna do this whole diagram with you guys on the Fibonacci sequence, even like on a very easy one like this one. It's just way too much. You guys can pretty much debug and learn about any recursion problems from the lesson that from the techniques that I just showed you. All right, so now one other thing I want to talk about, and I'm not gonna do this. The previous last year's video lesson, the person I was teaching, I think, did this on Chrome. Essentially, Stack Overflow, as you know, it's not just a website. Stack Overflow, I'm assuming, the website came from the fact that there is this thing actually called Stack Overflow, which is basically the maximum amount of call stacks that a program or your computer, right, depending on which environment you're in, allows. And so for Chrome, so in order to reach something like the max, call stack, you would do an infinite recursion. So no base cases here, right? So this, I'm not going to run this, right? I mean, it will tell me on my computer, I'm pretty sure, that at least on this computer, that, I only have, let's say, 1,200 stack frames, right? I think on Chrome, it's something like 16,000 or something like that. You can go find out yourself. You can do like so like a little trick that I would do, and I haven't written the code for it. Maybe you guys want to Slack me. Essentially, you can just do like instead of doing like a for loop, right, like a recursive way of counting from 1 to n, right? And then you just, for each, count, right, instead of doing like a for loop of for 1 to n, you just recursively call, right? And you just have a base case of when n equals 10,000, jump out. That's actually a little trick you can use to find out what's the actual maximum call stack that your system can handle without trying to break anything, right? So yeah, that's Stack Overflow. That's something that you should not be trying to do. If it does happen in Chrome, as you can see, it will tell you, okay, there's something wrong here. You've exceeded the maximum stacks. Most environments will tell you that. And yeah, so that's pretty much it. Yeah, so that's pretty much it. Yeah, so any questions from anyone? I think this one is pretty simple. Okay, all right. Okay, so if nobody has any questions, I guess we're good. And by the way, actually, before, oh yeah, go ahead.
I was just gonna ask, like, I'd like to understand recursion a bit more. It's something that I just touched on a bit. Is there in the slides some more reading or videos or stuff I can look into that you would recommend?
Yeah. Okay. So I will tell you. Maybe I should have put this in the story or something, like a story time. But recursion was for me something. I think what you're thinking. So I'm gonna try to relate it to you. I have a feeling I know exactly what you're feeling. Okay, so I'm gonna try to relate to you. So I have a feeling that you might be able to understand recursion somewhat, right? But then as soon as like you need to make a recursive, like you need to write some recursion, you might not understand it, right? I'm assuming there's probably, you know, that gap there. Or when you're even reading recursion, sometimes you're just like, I have no idea how this works. Is that kind of where you're at right now, Carmen?
Yeah.
Yeah. So the unfortunate thing is that this is something that takes a lot of practice, but I would say, so I would say for me, I didn't take like a specific course to kind of like understand it, right? So what I did was I kind of went through a couple, like there were some aha moments for me that made me kind of understand recursion. So the first one is, you know, whatever I just said, right? So I want to do, so I'm going to just go through this example right here. So I'm going to go, so I am going to give you this example. So essentially, there's only two things that you have to understand about recursion, right? Which is the one, which is the base case, because you have to jump out of it. And then two, which is the recursive part, right? So what I usually think is, okay, can I come up with a base case for, like, can I come up with the recursive part? And if I can how do I jump out of it, right? And so the one example that I really like is basically you want to convert like what I just talked about, the for loop, right, from 1 to n, right? So if you, I don't know if this will auto do it for me. Yeah, so something like this, right? Like for something like this, I just think, okay, again, there's only two things that you got to really remember, right? So for the recursive part, so this will go, let's say 1 to n, right? And so what I would do is I would just think, okay, I'm trying to print recursive from 1 to n, right? And so this is n. And so I just think, okay, in this one, if I was to call, so there has to be a recursive part, right, which is here, which is the function itself. And then this thing has to either get bigger or smaller. So I'm thinking, hold on, let me see, print 1 to n. Yeah, so what I would say here is, let's see, so you need to be able to jump out of this. So this could be either +1 or this could be like -1, right? Like, yeah, I'm just kind of guessing and speculating, right? Like this is not what it's going to be, but I'm thinking, let's say, okay, let's say we print, hang on, so we'll do a, yeah, we can console log here. So if we console log something out here, right? So we console log something, right? And then here we need to know our base cases, right? So for this, I would say if I do something like this, right? I want something from 1 to n. How do I do this, right? So I would say maybe we can do n-1 as a recursive case, and then when n is equal to 0, right? So okay, I am doing it backwards, but you know, bear with me. So when it goes to 0, then we bounce out of it, right? So this whole thing would look something like this. So essentially, yeah, essentially, what I did was I just thought of this has to go bigger or smaller. Whichever it goes, it has to stop. How do I stop it? I'll stop it when it gets to a certain case, and this is the base case, right? And so for me, I think this was the kind of aha moment because this was literally like the easiest program that you will ever come across, right? Which is basically console logging out 10 to 0, or 10 to 0, right? And so essentially this is recursion. So yeah, and so if we run it, I don't know if this is even gonna work. So let's, theoretically, I'm pretty sure it should work. Oh. There we go, 10 to 0. So for me, I would say if you want to learn more about recursion, I think you can, for me, I did questions on, like, I would say like trees and graphs. If you would take the time to look into those naturally have, like the recursive nature to it, right? So if you want something that's like simpler, I would say maybe go on LeetCode and find some. Okay, so there's a set of problems called backtracking, which is basically you can filter these problems. So filter backtracking problems, right? And so these are like the problems where you can kind of start seeing a pattern. So these are problems like the permutations, combinations of a string, right? So this is like the stuff that you'll see. Like if it's like ABC, right? What are all the permutations of it? It's going to be like ABC, ACB, right? BAC, et cetera, right? So I would say I don't really have one way of learning recursion. I would say it's just more about seeing more problems and then kind of doing it and then figuring out, okay, this is how it works, right? And so for me, I just, I've been programming for a while so I kind of been through a lot. And so that's why I've kind of developed an intuition. So I don't know if that's the best way to learn. I can't really tell you specific books or anything because, like I went to school, right? I studied computer science, and I felt like after I graduated, I still couldn't grasp recursion super well, right? And it's something I got better gradually over time, right? So I hope I answered your question.
Yeah, most definitely. Yeah, it's definitely worth one of those things where it's like it's all about practice, right? And yeah, I only asked because there was a few times where I was like on LeetCode and I was like practicing and like I would get it, but then there were like really intense ones. I'm like, oh, how do I get better at this?
Yeah. So that's why I think today it would be very beneficial because again, I'm not sure how you debug recursion, right? But literally, I would, if I didn't understand like this, right? Like if I don't know if there's a leak code question that says print from n to 1 or n to 0, right? But I would literally like, let's say, look at the solution and then just try to trace every single like thing via the call stack, right? Like actually try to trace it properly because that will give you a much better understanding, and then you'll start to see patterns on like um, how like other problems, especially like tree problems, deal with recursion. Yeah. Anyway, so all right, that's that. I think we're still recording, Michelle. I think